my name is James Narvaez. I'm here to tell you about temperature. Have you ever seen temperature? Of course not, because nobody's able to see it. Sometimes temperature can be hot, which means temperature is really full. But when temperature is cold, it's really close together. Now, what would have seemed if you tested out one in hot, one in a normal spot that they can stay the same, and one in a cold cup? I've never seen that, but I might try it today.
Take a look at the effect of temperature on chemical reactions. So I have light sticks because light sticks just look cool on TV, and I've got 3 light sticks. They're all the same color, and hopefully they're all the same brightness, and we're going to compare them here. They're all the same temperature right now because they've been sitting in the air. So you can see here that all 3 light sticks are approximately the same brightness, and of course they're all the same color. So we're going to take one and we're going to set it just in a jar and let it sit there at room temperature. We'll take another one and we're going to put it in this hot water here that's almost boiling and let it sit there. And we're going to take the last one and we're going to stick it down in some ice. And we're going to let that sit there. And let me flip this around a little bit more heat in there. Well, guess not. I'm going to set that in there and we're going to see what happens over time as each one gets colder or hotter or stays the same. And what we're looking for here is for the atoms in the cold one. The atoms in the cold one are going to get colder, and so they're going to slow down, and the chemistry is going to happen slower. All right, these are going to be the same rate that they always were, and the light stick in the hot water, the atoms are going to move faster, and so their chemistry is going to happen faster. Now the chemistry that's going on is a reaction that causes light to happen. So the faster the reaction, the more light that will be given off. And so even as we've just been letting it sit here, you can see that this yellow one here, even the bottom half is just bright compared to the top. So if I spread that out, you can see it's just getting bright because it's warming up, and so the chemistry is happening faster. This is still the same, and then the cold one is slowly cooling off. All right, so if I quickly compare the 3, you can see that the 3 temperatures, okay, the hot one clearly is much brighter than the everyday temperature one and the cold one. Now let's let them sit there for a little bit and we'll come back and see what happens after a little bit longer period of time. We're back now and we have the normal temperature light stick, which should be the same brightness that it always has been because it hasn't been too long. And then as we compare that, we can then begin to compare it with the one that was in the ice water. And hopefully the ice water one, there it is dimmer because it is colder, and so the reaction's happening slower. And then we compare it, of course, to the nice bright one that is warm or almost hot, and that's because the molecules are moving fast, and so the chemical reaction can happen fast. You make spaghetti by putting...
Temperature is a really good thing. When you have temperature, it's not that bad. Temperature sometimes stays the same for a little while, but then the next minute might change a little bit. And then in the temperature, when you do temperature, well, temperature, like sometimes you feel something really cold, that means its temperature is higher than 50. It's freezing. If you're holding it and it's really burning, yeah, that means it's something like lower than 50.
Heat and temperature are related but not the same. Oh, heat and temperature, to distinguish them is our aim. Heat is the sum of all energy. It's measured in joules and transfers from hot to cold. The heat is kinetic if it is used to speed up particles and raise temperature. But when heat is used to cause a change in the state of matter, temperature's high, but when they slow down, the temperature's low. But temperature is not, it's not energy, but temperature is a measure of the kinetic energy of the particles. Heat and temperature are related but not the same.
And I was talking about temperature. Thank you.